In this last video, I'll do one more quick example in number 5 about how to apply that strategy that we looked at in number 4 with solving a system of equations in order to figure out the multiplier and the y-intercept of your exponential graphs. If you prefer to use the guess and check strategy, I don't think you'll need a video for me to walk you through how to guess. But my suggestion would be, if you're going to do the guess and check strategy, make a table of values, because I think that's the most useful way of organizing your possibilities and visualizing the multiplication that needs to happen to go from 0, 16 to 4, 1. I'm just going to do the video on the exponential strategy with the system though, because I think that one is the one that's a little bit less intuitive, so I want you to have an example of that if you need it. The first thing I'm going to do is remind myself that I need everything to be in the structure y equals a times b to the x. So if I plug in the first set of coordinates, the first coordinates had an x coordinate 0, y coordinate 16. So I'll plug in y coordinate 16 equals a times b, x coordinate 0. Then I'll plug in again using the other point that they gave me. 4 is x and 1 is y. So that would look like 1 equals a times b to the power of 4. So that's going to be my set of equations. This is going to be the system that I want to solve. That's not the answer. Remember, I want to solve and find the values of a and b. So what I need to do is get one of these variables by itself to plug into the other function. I usually like to keep things simple, so I like to solve for a first, or at least get a by itself first, because I think that is the simpler looking variable, and I like to work with the simplest things I can when I'm solving a system like this. So I'll look at the first equation and I'll ask myself, okay, how do I get a by itself? Well, it is worth noting that b to the power of 0, or anything to the power of 0, is 1. So if 16 is equal to a times 1, then that means a is just 16. So that's kind of a nifty little trick, because that means I solve for a. A is already done. I know the a value must be 16. And now I can substitute that into my second equation, the more complicated equation, and now I can solve that one. 1 equals a, which is 16, times b to the power of 4. Now I need to solve for b. So I should get that 16 out of the way. I'll divide it to the other side, which means I'm working with a fraction, but that's okay. I have 1/16 equals b to the power of 4, and now I need to think, well, how do I get rid of a power of 4? This is kind of what we explored, if you remember, on page 7, like how do we solve equations with exponents, and we talked about lots of strategies that you can use, including things like radicals. So if I want to get rid of a power of 4, I know I need to use a fourth root, because the opposite of a fourth power is a fourth root. So I'll fourth root the left-hand side and the right-hand side both, because the fourth root will cancel the fourth power, leaving b by itself. That's what I wanted. And then the fourth root of 1/16 you can think of as two separate problems, the fourth root of 1 and the fourth root of 16. The fourth root of 1 means something times something times something times something 4 times is 1, but we know that's going to be a 1 because those are easy. Fourth root of 16 means something times something times something times something gives you 16 as an answer, and we know that 2 would work, so that means b must be a half. So I know now that the a value is 16, the b value is 1/2. Now I have the information that I need, and I'll go back to my original equation. Y equals, the a value is 16 times the multiplier is 1/2 to the power of x. Now this one worked out really fortuitously because of how easy it was to quickly solve for a right at the beginning. Sometimes it's a little bit more complicated, and I'll do one more example to show you what happens when it gets a little bit more complex. But this is generally the way of thinking about these problems so that you can make those substitutions as handily as you can. Some people may have argued, well, Herbert, you already knew 0, 16 was a point on the graph. That's obviously the y-intercept, so of course the y-intercept is going to be 16. I should have written the a value right off the bat, and that's true too. You can skip some algebra steps if you can interpret some of the information like so. Now in question letter B, the last one that I'll do here, I'll set it up just again so you have some structure, have an example to follow, and can see what happens when you have to deal with maybe less than nice numbers. I mean 1 and 3/2, not so nice. So I'll write out my structure, y equals a times b to the power of x, and I'll do both my substitutions. The first substitution is for x is 1 and y is 3/2, so I'll have 3/2 equals a times b to the power of 1. Then I'll do my second substitution, which involves x is 5 and y is 24, so 24 equals a times b to the power of 5. Again, I want to focus on these two equations. These are my original equations. I want to get the simpler one so that a is by itself. I chose a because it's a simpler variable. And then I want to be able to plug that into the more complicated equation so that I can solve the more complicated equation easily. So I'll start with this top equation because it looks a little bit simpler. B to the power 1 is just b. So I have 3/2 equals a times b. Now you can get either variable by itself, it doesn't matter which one, but I'm looking ahead and thinking a just looks simpler in the equation I'm eventually going to solve, so let's just solve for a and keep things as simple as we can. Now if I divide by b, it might be unclear how to divide by b on the other side, so instead of dividing by b, let's think of this as maybe multiplying by 1 over b, which is the same mathematical effect as dividing, but if I multiply on the other side by 1 over b, then I'll clean this up and I have 1 times 3, which is 3, over b times 2, which is 2b, equals, those are canceled, a by itself. Now again, hopefully you're with me here, and hopefully you can see how I got that, because this is what I want to substitute for the letter a in the more complicated equation. Now I want to solve the more complicated equation as 24 equals, I'm not going to write the letter a, I'll write what I just got, 3 over 2b times b to the power of 5. Now, as always, try to make the equation as doable as possible. If you don't feel comfortable with fractions, you could throw this b over 5, or b to the 5th over 1 and just clean it up. So you'd have 24 equals 3 times b to the 5th is 3b to the 5th. On the bottom, 2b times 1 is 2b. This does clean up a little bit, I mean not a lot, but 24 equals, we could clean up one of the b's, so you'd have 3b to the 4th over 2. It's not ideal, but it's certainly not terrible. We can do this. Let's try to solve for b. We can multiply by 2 on both sides to get rid of the fraction. That would be a good thing, especially for those of us who hate fractions as it is. So if I get rid of the fraction, then I have 48 equals 3b to the power of 4. Then I can divide the 3 to both sides. That'll get rid of it on the right, and I'll have 16 equals b to the 4th. And then I can say, just like I did in the previous example, I need to get rid of a power of 4, so I'll use a 4th root on both sides to get rid of it. 4th root cancels 4th power, so b is by itself, and the 4th root of 16 is something times itself 4 times. It gives us 16 as an answer. Oddly enough, there are actually 2 possibilities, and I didn't actually mention this in the first video. There are 2 possibilities in the first video as well that I didn't really go over. Let's keep things simple. Let's just keep things positive. 2 times 2 times 2 times 2 4 times is 2, so we'll just stick with positive 2. It is possible that you could also have negative 2, but I'm not going to worry about that so much. Like I said in a couple of videos ago, it's not really that big a deal if you do the plus or minus thing right now. You're just looking for an equation that works. You don't need to find every possible equation that works, so it's fine if you just limit it yourself to the positive 2 here. If you know that b is positive 2, now we can say to ourselves, well, that's important. That's the multiplier. But now I can go back to either of my original equations, plug 2 in, and then I can solve for a. Doesn't matter which one you want to plug into. If you're like, ooh, I don't like the first one has a fraction, then you can plug into the second one. It doesn't matter where you plug in. So if you want to plug into, say, the second one, 24 equals a, we don't know, times 2 to the power of 5th, then 24 is equal to a times 2 to the 5th is 32. And if I divide that 32 to both sides, it's not going to work out nicely, but I'll have a is equal to 24 over 32, or you can reduce it. It looks like you could reduce by 6. So you could reduce by 6 and get, or sorry, not 6, what am I saying? You could reduce by 4, or you could reduce by 8. Actually, 8 would look better. So 8 goes into 24 3 times, 8 goes into 32 4 times, so a reduced answer could be 3/4. But now that I have the possibility there, I know that my equation is y equals a 3/4 times b 2 to the power of x. You'll notice on the answer key I also included the possibility if you came up with -2 as a possible answer. So if you want to go back and check both possibilities, you can. You just don't have to write both. It's your choice. The remaining problems on this page will essentially be more practice of the same. If you don't want to solve it this way, you don't have to. Guess and check with a table is fine. Guess and check in a calculator is fine. Use your best discretion. But the last thing I'll say is don't worry about doing question number 9 unless you really want to challenge yourself. Question number 9 is a good question, but it involves a percentage, which can be a little bit trickier to do. And we've never really talked about percentages. So if you want to challenge yourself with number 9, that's great. And if not, just finish through number 8 and try to practice, because it's a lot of the same skill over and over again.